Let's take a look at Spiricam. So Spiricam is a piece of software that I wrote about a month ago that processes the output of camera devices in such a way as to bring information out of the noise. But let's begin by recording a little bit from our webcam. In this case, I have a webcam that is pointing at a page in a notebook, and it's partially exposed to light. And when I click start here, it takes a few seconds to start up, and then it begins to collect some frames. And as you can see, it's picking up a cross-hatching from the notebook. Okay, I'm going to hit pause. I've collected 29 frames. I'm going to turn off all the filters for now because I want to share with you that in the beginning here, we're just literally collecting the output of a web camera. There are two sliders that control camera capture. The first one is exposure, which controls how long the shutter is open per frame. -13 corresponds to about 100 microseconds, and -1 corresponds to about a second. The gain is not available in all webcams, but it controls how much amplification the circuits in the sensor are used. Set it to 255 to get the maximum amount of amplification. Set it to 0 for the minimum number of amplification. So there are two principles involved in Spiricam. One is that instead of looking at the frame directly, we look at the difference between the current frame and either the previous frame or an average of the last few previous frames. So as you can see here, I selected now one frame for the background. So we're literally subtracting now the current frame from the previous frame, and we can scan through using the frame index at all these differences. Now, once again, if I remove the background frame and we just looked at the collected images, we would see that we just have the regular image that we collected. But when we apply at least one frame as background, what we're seeing is the difference between frames. And so this then really picks out a lot of the noise from the camera sensor and the difference in terms of the light collected between each frame. And this is where we hope to pick up interesting anomalous signal. As you can see here, in just scanning through the differences, there's a little bit of structure in the noise. There's like a few vertical lines, but generally it's not too much. You can also then apply Flattened Spectrum, and this gets rid of a lot of the features that it's picking up. If you want to collect with the lens cover on or in a black box, you can do that too. That would also remove any of the features of the environment. All right. As you can see here, I've clicked on this Flattened Spectrum. What this does is it takes away a lot of the features from the actual image. Now we can go back and select the background to be 0 and then turn on and off the Flattened Spectrum. You can see that this also is reducing features, but it's doing it on an individual frame basis. And you can still see a little bit of edge detection even when you flatten the spectrum. All right, leaving the Flattened Spectrum on and turning on the frame difference to 1, we can now apply the next big feature of Spiricam, which is the ability to apply a blurring type function similar to what's used in Pearl and noise. And usually I like to set the value to 1.3 or 1.4. And as you can see here, this really sort of takes the noise and it turns it into what looks like smoke. And you can use either the color mode to find features, interesting features, or you can go into black and white. And I find black and white is often has a little bit more information in it. It's an averaging over red, blue, and green sensors, and it starts to pick out more interesting features. Some other things you can affect are the BIOS exponent, which affects a little bit of the smoothness and picks up other images. So both the radial exponent and the BIOS exponent can be played with however you would like. And these just affect a simple mathematical transformation that's occurring to the frequencies of the image. Basically what we're doing is we are inverting the frequencies. What does that mean? Well, it means the strength of low frequency modes is being amplified and the strength of high frequency modes is being reduced. So if we go back to radial exponent of 0, we see a lot of high frequency type dusty noise. And then as we increase the radial exponent, we're bringing out larger and larger scale features. Meaning we can continue to go further, and we almost get sort of like a sign flip, so that we're picking up both dark and bright areas. But around 1.2 to 1.8 seems to be where a lot of the interesting stuff occurs. And so this is doing a certain amount of averaging over the dusty noise, looking for features. There's no machine learning in this program as of currently. And so any features that you see are actually coming from the noise itself and the transformation of that noise. Now there's a few other dials here that you can play with. These two threshold sliders are just affecting sort of like the brightness and contrast, like where, like here we're brightening up the white areas, here we're darkening up the darker areas, and this can help you isolate features. Spectral subtraction is an experimental feature to try to remove noise in the image, but it doesn't actually work when you flatten the spectrum. You would have to unflatten the spectrum, and then you can begin to reduce different frequency modes. If you go really far, sometimes you'll find that you get almost interference patterns. All right. You can also, in black and white mode, you can select which channels you want to emphasize, the red, green, or blue channel from the sensors. I typically like to just look at all three channels added together. And once again, you can switch between color and black and white. Color is a little bit harder, I think, for spirits to work with because it requires that they align their imprinting in all three sensors. When you do black and white, you're essentially just asking for an average or just to simply affect the luminosity of the image. And we tend to get a little bit more detail in black and white. Now, if you see something that looks interesting to you, and for example, it's off the screen, you can use these sliders here to center your image however you'd like. And you can click Save Frame to save that frame to disk. Nothing else is saved after you stop the program except the images that you click Save Frame on. So go ahead and save anything that you find interesting. Here I see a little bit of a face here. There's two eyes, a nose, and a mouth. I also see something that looks like somebody squinting with a nose and a mouth. Might be an image, spirit image, might just be our hallucinations of faces and noise. But we can click Save Frame again. You'll find that you'll get a lot of interesting, almost like cartoonish looking faces if you look carefully enough. Are these actual spirit faces, or is it just something called pareidolia? That remains to be seen. For now, I would consider this program to simply be suggestive and possibly helpful for both spirit communication and ghost research. For example, here I see like 2 eyes, a nose, a mouth, sort of a face. Of course, it looks very interesting looking face, perhaps an ear, perhaps some hair, fuzzy hair up here, who knows. I see something else here. It looks like 2 eye sockets, a nose, a mouth. You can imagine a lot of things if you look carefully enough. Here's some hair, here's 2 eyes, a nose, a mouth. Once again, you can save it for further analysis and any sort of other image processing you'd like to put on it. The benefit of this program over, say, the software that is provided from France, the fractal Perla noise, is just the ability to, adjust the filters as you want onto each image, and also the fact that we can collect the images directly from a camera. However, if you so choose, you can also select different devices if you have multiple cameras hooked up to your computer. In this case, I've selected camera number 2 because camera number 1 is a droid cam, which is basically can receive images from the cell phone camera. If I go down here, I can also select pseudo-random. So now here, when I generate images, I'm actually just generating pseudo-random noise on my computer, which I'm not entirely sure where the seeds are coming from, so there could be some magical effect from Spirit producing the seeds that would produce face-like images. You could also consider this sort of a baseline as what happens if I just take pseudo-random noise and I run it through the filter. What kind of features do I get? What kind of faces do I get? And you can see here, 2 eye sockets, a nose, a mouth, 2 eye sockets, a nose, a mouth, and you think, oh wow, I can get faces from just pseudo-random noise, which technically is deterministic. However, the seeds could be based on the time that the random command was called, and that could theoretically be affected by some external sources. Once again, we can see some interesting, if you really look hard, if you play with this program enough, you'll start seeing faces and everything, because our face detectors just get overloaded and we start to see things where there isn't anything. But nonetheless, very artistic how the noise is being transformed here, and it's a very simple function. Once again, no machine learning or anything. There's no implicit bias towards faces or any objects that you might encounter in here. So yeah, you can then compare, of course, the faces and the images that you get from pseudo-random noise. Here's 2 eye sockets, a nose, a frowning mouth. And you can compare that to what you would get if you ran a camera and computed noise from taking the difference between frames selected from a camera. So now I'm running that, and here it's computing a bunch of frames from that camera, then computing the difference. I can hit pause, and once again we can get similar looking type things, and you can decide for yourself if there's more or less faces using your camera or just generating random noise. Or maybe you believe that the faces can come through pseudo-random noise also. So that is a general overview of my program. There's finally the exit key when you're ready to exit the program. If you have any other questions, go to our forums at veranormal.com and find out more about what's going on in our ITC research. And you can use that forum to contact us to get a copy of the software, so you can play with it yourself. I've written it so that it's fairly easy to use and should work in the Windows platform, But of course, if there's any problems, we will try to iron them out. Thank you.